Today we are starting chapter 9, which is systems of linear equations. So we're going to start with this first method that we're going to talk about for solving a system, and that is the graphing method. And this is a very basic method. It gives you a good visual of what it is exactly that you're doing when you're solving a system, but it's also the least accurate. So we do it first just to kind of get an idea of what we're really doing, and then we move on to the more algebraic methods. When you get to high school, you will do graphing, but you'll use a graphing calculator, which will give you a very exact answer. Okay, so let's get started. So two or more equations in the same variables form a system of equations. So what that means is if I have a couple of equations and they all have x's and y's or x's and y's and z's, then we say that they are all in the same variable. And so they form a system of equations. So to solve a system, you must find all the ordered pairs x and y that make both equations true. Since the solution of a system satisfies both equations at the same time, the system is often called a system of simultaneous equations. So you're either going to hear them being called simultaneous equations or system of equations. I always heard them as simultaneous equations when I was growing up. That's what we learned, was simultaneous equations, but it's just different words for the same thing. So solving a system or solving simultaneous equations means the same thing. Okay, one way that you will see systems or simultaneous equations um, written is like this. I have this brace here on the left-hand side, and then I have these two equations. So this brace indicates that these two equations form a system. Okay, and what I'm going to do is I'm going to solve this system, and I'm going to solve it by graphing. So I'm going to start by graphing the first equation. And what I want to do before I graph these, I want to put them in slope-intercept form just to make them easier to graph. So I'm going to write them down here. 2x minus y equals 8. So I would have negative y equals negative 2x plus 8. I divide everything by negative 1, and I get y is equal to 2x minus 8. So if I graph this, and of course naturally it doesn't fit on my graph. So here's 6, here's 7, 8 is going to be right about here. Actually, it's going to be right down here. It's negative 8. Duh. All right. And then my slope is 2, so I go up 2 and over 1, and up 2 and over 1, up 2 and over 1, up 2 over 1. Okay, and then I need to use a straight edge, and it's super duper important that you use a straight edge to graph these because accuracy is super important in order to get the right answer when you're graphing a system. So here's my straight edge, and I want to make sure that I am matching up all these little points. Okay, and again, I make sure that my graph covers the whole length of the coordinate plane, and I put the arrows on the end to indicate that they are going on in both directions forever. Okay, I take my second equation then, which is x plus y equals 1, and I write that in slope-intercept form. That was a little bit easier. My y-intercept is positive 1, and my slope is negative 1, so it's down 1 over 1, down 1 over 1. Okay, and I can already see where they're going to intersect. Okay, so then I draw that one. Again, trying to be as accurate as possible. And so here are my two lines grafted on the same coordinate plane. And as we can see, they intersect right here. And where they intersect, that point is 3, negative 2. So 3, negative 2 then is the solution. Okay, it's 0.3, negative 2. And basically what that means is it's the point that makes both equations true. So the solution to a system is the point or points that make every equation within that system true. So 3, negative 2 is a point on this line, and it's also a point on that line. It's the only point that both lines share, so that is the solution. And we can double check by plugging in. So 2 times 3 would be 6, 6 minus 2. 6 minus negative 2 would be positive 8. 3 plus negative 2 is 1. Okay, so this is the solution. Make sure you write your solution as an ordered pair. Ordered pairs have to be in parentheses, or they're not an ordered pair. They're just two numbers. All right, let's look at our next one here. Again, I'm going to put them both in slope-intercept form because that's the easiest way to graph them. So if I start with the first one and try to do it correctly this time, this will be negative x minus 6. I divide everything by negative 2. And I get y is equal to 1/2 x plus 3. So 3 is my y-intercept. My slope is 1 over 2, so it's up 1 over 2, up 1 over 2, up 1 over 2. And again, I want to use my straight edge to graph that as neatly as possible. I want to be super accurate because we're looking to see where they intersect. So if my lines are kind of sloppy or inaccurate, I'm not going to get the right answer. So there's that one. And then I have x minus 2y equals 2. And I'll have negative 2y equals negative x plus 2. Divide everything by negative 2. And I get y is equal to 1/2 x minus 1. And here's negative 1. And my slope is a 1 over 2, so it's up 1 over 2, up 1 over 2, up 1 over 2. And I'm going to connect those dots. And if we look at it, they're parallel. Okay? And if they're parallel, they're never going to cross. So if they're parallel, there's no solution because there is no point that they both share. Another way that I could tell that they are parallel is if I look at my equations that are in slope-intercept form, notice that they have the same slope. Okay, so two lines that have the same slope are going to be parallel, which means there's no solution. There is no point that makes both equations true. All right, let's look at the back. All right, so here we have another one. Again, we have two equations. I'm going to put those equations in slope-intercept form. So 2x plus 3y equals 6. 3y equals negative 2x plus 6. Divide everything by 3. And I get y is equal to negative 2/3 x plus 2. So let me graph that. There's 2. I'm going to go down 2 and over 3 and down 2 and over 3. Let me graph that. Again, try to be as accurate as I can. And if I do the second equation, here's my first equation. If I do the second one, 4x plus 6y equals 12. 6y equals negative 4x plus 12. If I divide everything by 6, I get y equals negative 2/3. I'm going to simplify that, plus 2. Look at this. They're the same. Okay, so if I graph the second one, it's just going to be exactly the same as the first one. So when I have the same line, which can happen, I have infinitely many solutions. So there's an infinite number of solutions because this line goes on in both directions infinitely. So there's an infinite number of solutions, and they all make both equations true. And what this means is that these two equations are equivalent equations. Equivalent equations. If you think about equivalent fractions, like 1/2 and 10/20ths are the same. It's just two ways of writing the same thing. These are equivalent equations, just two different equations, two different ways of writing the same equation. This one, if you divided everything by 2, you're going to get the first one. Okay, so those are, so there's three scenarios that we've looked at. They intersect in one point. That gives us a solution of a ordered pair. They're parallel, okay, which means there is no intersection, so there's no solution, and that's what you would write, no solution. And a third scenario is they're the same line. They're equivalent equations, and they're the same line, which means there are infinitely many solutions. And this is what you write. You write infinitely many solutions. All right, so let's look at the try this. We're going to graph this and solve it. So if I start with the first equation, 2x plus y equals 2. I'm going to put it in slope-intercept form. So y is equal to negative 2x plus 2. And I'm going to graph that. My y-intercept is 2. My slope is negative 2, so it's down 2 over 1, and down 2 over 1, and down 2 over 1. Again, I very carefully graph that using my straight edge. If you're not using a straight edge, it's not going to work. Okay, so there's the first equation. I take the second equation, x minus y equals 4. Get negative y equals negative x plus 4. Divide everything by negative 1, and I get y equals x, 1x minus 4. So here's negative 4. And my slope is positive 1, so it's up 1 over 1, up 1 over 1. We can see right there where it's going to intersect. So I connect those dots. And the point of intersection is right here, and that is 2 negative 2. So there is my solution. Please make sure you write it as an ordered pair.